Okay, so how are we going to solve this situation? Remembering that our steps so far are remove fractions by multiplying, and then solve like before. So, well, let's take these one at a time. I'm going to deal with this side of the fraction first, and this divided by 5x. So I'm going to multiply both sides by 5x. So that leaves me with 6 over here. It leaves me with 2 over x plus 2 multiplied by 5x. Now, rather than work this out, which I could do, I'm going to deal with this other denominator first. And you'll see why then. And over here, later on, I will show you how I would do that multiplication. So, I've got divided by x plus 2, so I'm going to times by x plus 2. So this side becomes what's left. Now that looks a lot nicer, doesn't it? And this side becomes that. Much better. So here I can expand and get 6x plus 12. Here I'm going to get 10x. Solving as normal. I've got x's on both sides. I'm going to take away the smaller one. Now, if you feel unsure of this, what you need to do is you need to watch the video on part 9. So, take 6x off both sides and then divide by 4. Let's continue on. There are 3 more I'd like you to have a look at. So start at the top. 3 over x plus 3 equals 16. So this 3 that's over here by itself, I'm going to deal with first. So I'm going to subtract 3 from both sides, which will leave me with the 3 over x equals 13. Now this should look familiar because it's very similar to the situation we faced at the start of the previous part. Pause now if you need to read this for longer. So, multiply both sides to get rid of the fraction. Have a look at the situation now. X has been multiplied by 13, so I divide by 13. Which would sound horrible, but I leave everything as a fraction. So the key point here was this plus 3 on the end It's not part of the division. It's a lone term like that, so I can take that 3 off straight away and make things a lot easier. Look here now. I've got 2 unknowns, but they're both on the same side, and they're both parts of fractions added. Think back to your rule for adding fractions. It was, you need the same denominator. So let's make them have the same denominator. Well, if I double this one, I can get 2x as my denominator. This is the same as if I had denominators of 4 and 8. What would happen now when I try and add these? The denominator would stay the same, and the numerators are added. We've then got to get rid of the fraction, multiplying by 2x. Then we've got to get x by itself, which is dividing by 8. The same patterns get done over and over again in terms of steps, and by now some of you are going, I can see ahead, I can think ahead of you. That's good. Let's look quickly at a case of multiplying now, and then try and round this topic off. So, the rule for multiplying fractions is look for cross-cancelling. Good. I don't think there is any here, so I'm going to multiply the numerators. 7 times 2x is 14x. X plus 1 times 5. Well, that's 5 lots of x plus 1. And we always put the number at the start outside the bracket. Remember, this means multiplied. I'm now going to multiply by my denominator. Remember, keep thinking along ahead of me to try and work out what the next step is. Some of you might have wanted to write this straight away. Well done if you did. Expand the bracket. 15 times x, 15 times 1. Again, using part 9 of the video, subtract 14x, the smaller one, from both sides. And now subtract 15 from both sides. The key principles here were remove the fractions and then expand brackets and solve as required. In part 9 we're going to look in real detail at solving equations with unknowns on both sides.